Welcome. In this video, we're going to be discussing discrete uniform distribution. So in statistics, there are many variables that take on similar forms that we will specifically identify because they're used often. They have many number of applications. So one, and in fact the simplest discrete random variable that there is one that only assumes a finite number of possible values, and each of these possible values has equal probability. This being the discrete uniform distribution. So if a random variable x has a discrete uniform distribution, that means that each of the n values in its range, x sub 1, x sub 2, all the way up to x sub n, have equal probability. Then f, our probability mass function, f of x sub I is going to be equal to 1 over n. Now, while you may not have designated it as a discrete uniform distribution, you have encountered this many times. Whether you're talking about flipping a coin, there's only two outcomes, heads and tails. Well, each of those outcomes has equal probability. Well, assuming you're flipping a fair coin. You could also be talking about rolling a six-sided die. If you're rolling a six-sided die, each with equal probability, well then the probability of getting a 1 is 1/6. Probability of getting a 2 is 1/6. So on and so forth. You could roll any other size die, a 20-sided die, for example. Each one of those values has a probability of occurring of 1 over 20. Now, if we have a discrete uniform distribution for a variable x on consecutive integers, starting at a, then going to a plus 1, a plus 2, so on and so forth, until we get to b, for a less than or equal to b, then that means that our mean of x, our expected value of x, is going to be b plus a over 2. Now, it's important to notice that in our definition here, that it's talking about consecutive integers, starting at a and then going up to b. We'll look at an example in a moment where this fact plays a part. Also, the variance of x, so sigma squared of x, is going to be equal to the quantity b minus a plus 1 squared minus 1 divided by 12. So let's actually look at putting that into practice. So let's say that y is a discrete uniform random variable that takes on the values 0.2, 0.4, 0.6, 0.8, and 1. Now, what we want to find is the expectation of y and the variance of y. Well, one thing to notice is, again, going back to the definition for mean and variance, we can only use these formulas if our discrete uniform random variable is defined over integers. A plus 1, a plus 2, so on up to b. For y, it's not defined that way. We're defined at 0.2, 0.4, 0.6, 0.8, and 1. So we want to find the expected value of y and the variance of y. To do this, we're going to need to create another variable so that we can satisfy this condition that our uniform random variable is defined on integers. So what we're going to do is we're going to let x have a range of 1, 2, 3, 4, and 5. Now, if x is the values 1, 2, 3, 4, and 5, then that means that y is equal to 0.2 times x. Now, x is defined on integers ranging from 1 up to 5. So that means we can use these formulas to find the expectation and variance of x. So our expected value of x is defined to be b plus a over 2. In this case, b is going to be 5, a is going to be 1, so we're going to have 5 plus 1 over 2, so 6 over 2, we're going to end up with 3. Now, we can also use these formulas to find the variance of x. By definition, our variance is b minus a plus 1, that quantity squared, minus 1 divided by 12. Well, b is 5 minus a, which is 1, then plus 1, that quantity squared, minus 1 divided by 12. So we're going to have 5 minus 1 plus 1, that's just going to be 5. So 5 squared is 25. 25 minus 1 divided by 12. So we're going to have 24 over 12, or our variance of x is going to be 2. Now, we're not finished. What we found is the variance of x, this variable that we created. What we set out to find initially was the expectation and variance of y. Now, to do that, we can use previous formulas that we have looked at. So the expectation of y is going to be equal to the expectation of 0.2 times x. Now, we can then pull that 0.2 out. So we're going to have 0.2 multiplied by the expectation of x, which we found a moment ago to be 3. So we're going to have 0.2 times 3, which is going to equal 0.6. Now, we can also use this to find the variance of y. So the variance of y is going to be equal to the variance of 0.2 times x. Now, when we're dealing with variance, when we have a constant and we pull it out, we have to square that constant. So we're going to have 0.2 squared times the variance of x. So we're going to have 0.2 squared is going to get us 0.04. So 0.04 times the variance of x, which we previously found to be 2. So 0.04 times 2 is going to get us 0.08. All right. So that will conclude our discussion of the discrete uniform distribution. Thank you.